this video, I'll explain how to draw a parabola like this using AutoCAD. So first we will be taking a line. Before taking the line, we need to on the ortho mode so that our line will not get deviated. So first we'll take the line and draw a vertical line which is called as Directrix. It can be of any length, and onto this line we will draw a horizontal line. For our question, it is 50 millimeters. So we'll be writing 50. And now we're going to divide this into two parts because as per the eccentricity of parabola, it is 1. So 1 by 1. So adding 1 from numerator and denominator, we get 2. So you get this div option. And sometimes you don't get the point. So you can type P type and select the point. So you can get the visible intersection points. Next, you can see the distance is 50 as per the question given. Now we will be pointing the intersection point here. So these are the vertex point and the focus point as per our question. Now we need to select a circle from V to F, the radius, and draw a line from V to that circle end. Now we got a line from this point to that point of intersection. We'll draw a line. Now type TR, enter, tracing the line. So we will remove the extra lines, and now what we need to do is to extend this line that we have drawn. Use the lengthen option so that you can lengthen it easily. Now we need to move on further, similarly doing the same thing. So we will also extend the line of V to F. That will be extended, and now you can type offset and enter 10. This is a normal distance that we can consider. So select the V and drag the cursor right side, and similarly for all other lines you can get it in this way. Now you have to type extend and double enter, and then you can select these lines to extend easily. Now this is extended. Now we will take the text and number each of the lines that we have created. So you can use tab to get the exact spaces. And next we will also label the numbers in the upper ends. So to label that, what we're gonna do is first you select a text in that you write 1- and you copy it using the copy option. You can see here, select that number and just drag it wherever you want to place it. First you need to select where we want to place, and from that you can drag and drop. Just simple, it's easier than by typing. And then we can double click on each text and rewrite the correct numbers whichever we desire to. So I'm gonna write it quickly here. Now we have numbered each and everything clearly. Our next step is to select the circle and place it from 1 to 1- and select that circle, place the center to the focus point, and wherever the intersection happens in the line 1 to 1-, draw a intersecting point. And similarly for all other lines that we have here. So take the circle to point 2 to 2- as the radius, and select the center of the circle and place it to the focus and draw the intersection point wherever it is intersecting. In similar way we will be doing for 3 to 3-, expanding the circle radius to 3 to 3-, and then placing it onto the focus point, and intersecting points are drawn properly. In the same way we have to select the radius 4, 4-, 5, 5-, and so on, and the center of the circle will be placed on focus and will be cutting the intersecting points wherever the line gets cutted. So as you can see, this is how we will draw the intersecting points. Now we need to join all these points and make the parabola. So we will be using a spline line. You have to connect all these dots and get the curve that we desire. So at the end of the point, right click the point and press enter or select the enter option. Now this is completed. This is the half part of the parabola. You need to select this curve and you can show it more clearly by selecting a different color and thickness of the line. We need to select this completely and use the mirror option to get the other part. Select no so that the actual part won't get disappeared. We can remove the extra details that we have drawn. Now we will be labeling the directrix and also the axis and all other important points. So we will be using the same technique that we have used earlier. So this process of making parabola is similar to the one ellipse. So if you haven't checked out, you can check the ellipse video that I have made. Same process, just the eccentricity part is different. This question asks us to draw a tangent and a normal. For that, the distance from the directrix to the curve parabola is 60. So we'll be taking a circle from any point on the directrix, and wherever the intersection happens from the circle to that parabola, we will be drawing an intersecting point. I have marked it with a red color intersecting point. From there, we will connect that intersecting point to the focus with a line. And now we need to select this line. I'm highlighting this line by increasing the thickness and all the coloring, everything. Now we will select this line and copy it and paste it onto the focus point. So we will be making a perpendicular line from it. Now we will select that line and click on rotate option and select the point focus, enter 90 degree so that it will be a perpendicular line to each other. Now wherever the directrix get cutted, from that point to this point we can get the tangent line. So this will be our tangent line, and in the similar way we will be doing for the normal. Click on the line and rotate it using the rotate option. So this perpendicular line which is perpendicular to tangent, that will be our normal, and I will label the lines as normal and tangent. So this is our complete parabola with normal and tangents. I hope you all understood. So let's label it as CD, the axis. So completely we have finished our parabola. Thanks for watching.